I want you to take note that there is a slight difference between the two SS model in the two state space models that we have derived. Okay, so in the next slide, we will show you that these two will come up to a similar transfer function. Here, this is the solved or the derived state space model. Okay, and while on this part, this is the converted version, no, of the state space model. So we first derived using the procedure in how to derive the state space equation, while on this part, if you recall, no, we converted the transfer function into a state space and we come up to this solution. So have a particular um, note, no, that itong highlighted ay may mga difference sa kanila. Okay, next we're going to do is to convert these two to a transfer function. So once more, here is our converted transfer function here. And take note, for the converted from transfer function to state space, we have here 1 and then -6, -4. No? Yun yung mga difference nila as compared sa derived, no, state space equations. So instead of 1 here, we have here 1/2, and instead of -1/6 and -4, we have here 1/3 and 1/8. So observe the difference. In the next slide, we'll convert the state space back to TF for the two equations. So let us first do from the converted state space model, we convert back to transfer function. So note that the converted state space, we have here 0, 1, -1, 6, -4, and then 0, 1 for matrix B, and then -1, 6, and -4 for matrix C. Okay, so what will we do is to write the general form of our transfer function. We need to derive ys over us. And from our slides, from our PowerPoint presentation, I have shown you there that the formula for solving ys over us will be equal to the matrix C multiplied by the x sub 1s, okay, and times b. I think this is inverse, no, the inverse of x sub 1s, no, times the matrix B plus the matrix D. Okay, and transposing us on the other side, ys will be equals to c s x s times b times us plus d us. Okay, so to recall, note that the A, matrix A, is 0, 1, -6, -4. The matrix B is 0, 1. And the matrix C, okay, it's -1, 6 minus 4. Okay, so I hope you recall the standard notation of the state space equation. Okay, so RD is 1. So note also, no, from our PowerPoint presentation that the sub x of 1s, it should be inverse, no, is equal to si minus a inverse, no, of si minus a. So therefore, ys equals to c times si minus a inverse times b plus T. Okay, multiplied by the input US. Okay, so let us now first solve for the Si minus A raised to negative 1. Okay, so solving, we need to subtract A from identity matrix multiplied by S. S matrix. So S matrix times identity matrix will give us S00S. Now it's a 2 by 2. We need an identity matrix of 2 by 2 because our A is a 2 by 2 matrix as well. So we could subtract the two matrices. So S minus 0 is S, 0 minus 1 is negative 1, 0 minus negative 1 over 6 is positive 1 over 6, and S minus negative 4, so S plus 4. Now, to take the inverse of Si minus A, that is equivalent to the adjoint, no? Adjoint of the matrix over the determinant of the matrix. Okay, so this is the determinant, and then solving for the adjoint. Okay, so this is the standard equation, no, of solving, no, of the inverse. So this is the adjoint, no, wherein we this one we uh, replaced, or in yes we replaced A with D and D with A, and then negate the value of B and C. So therefore, with this matrix, okay, taking the inverse of this matrix, that will now give us, okay, okay, so we rewrite first. So this is the matrix. Taking the inverse of this matrix will be equal to, so 1 over the derivative, the determinants, no, of the this matrix. So S times S plus 4 minus negative 1 times 1 over 6. Okay, and the adjoint will be S plus 4. No, notice na nag-interchange yung A and saka D. S plus 4 here and S here, and then the negative 1 will be positive 1, and the negative 1 over 6 will be magiging negative, no, kasi positive siya originally. So simplifying, therefore, our inverse of Si minus A would be S plus 4, 1, negative 6, S all over, it's S squared plus 4S plus 1. Okay,